Okay, so I'm actually going to mute you unless you want to mute yourself.
Yeah, I'll mute me.
Okay. You can unmute yourself if you have a question. So simplifying radicals, this is specifically, so I already have a video on simplifying radicals in general using the multiplication property. This is going to be using the order of operations, and these are mostly going to be radicals that involve fractions. So I didn't, in my other video that I have linked in the classroom that has the same sort of title that's multiplying, there's not any fractions involved. So a lot of these involve fractions. There are going to be some with addition and subtraction. And so that's why they're labeling, the textbook says using the order of operations in this particular section of the book. So I'm just following their lead, basically. So just if you've watched those other videos, then these slides are going to look very familiar because I'm basically reusing the same introduction slides here. So we've got the multiplication property of radicals where, so the square root symbol in general is called the radical symbol. And if there's a number right above the V part, that's not, usually we don't write a number for the square root, we leave it off. But if there's another number there, like 3 or 4, then we use the general term radical or root. And so that could be like the third root or the fourth root. And that's the index. That is just telling you what exponent you're trying to rewrite things as so you can simplify. The square root would be an index of 2, and we just don't bother writing the little symbol there. But the multiplication property basically says that if you're multiplying radicals, you can combine them into a single radical. And you can do the reverse. If you have one radical, you can split it up into 2 separate radicals. And this helps us simplify these things. We also have the division property, which works basically the same way, is that if you have a fraction going on or division inside a radical, you can split it up as 2 separate radicals, and then you can also reverse it. You can combine them as one separate one if you want. So those are 2 handy rules used for simplifying radicals. The multiplication property is going to be used the most once we start working with the quadratic formula, which is, I think, the last section covered this week, because you're simplifying radicals, you're simplifying square roots, basically. And so we use the multiplication property to do that simplification. You won't really use the division property too much with the quadratic formula because we generally will not have a fraction inside the square root, though it is possible with the quadratic formula. You can actually end up with some with fractions in there, and then it can kind of get messy. So in general, when we're simplifying a radical, our goal is to make whatever numbers are inside there as small as possible. And when we do this, what happens is numbers usually end out in front of the radical, multiplied by the radical. Anything with variables on the inside, we want the exponents to be as small as possible. In this process, often results as removing things from the radical, and then exponents end up outside of it. And so when you're doing this process, a lot of things end up on the outside of the radical, and you want to put as much outside as possible, because then we can add and subtract and do a whole bunch of things with them. When things are inside radicals, they're more difficult to work with because we basically can only multiply or divide. We can't really do much else. So any exponents on the inside should be smaller than whatever the index is. So if you have a square root, you don't want to have any exponents on the inside. You don't want to have any fractions with your square root symbols or radicals on the denominator. We like to put them on top. And we don't want to really keep any fractions inside our radicals because it's just harder to work with. So those are the general rules. So I've just got a series of examples here. And like I said, these are all going to be mostly fraction ones, because that's the other part. My other video covers just the multiplication. So here we're going to be using the division property and to simplify these radicals. And so to do this, we're going to have to use some of our rules of exponents that we learned. And then I've got a few examples in the back that are very similar to what it looks like when you have the quadratic formula, so you can see how you simplify within that. So first on the left here, I've got the square root of 80 over 5. So the first thing to do is to say, can I divide that into a whole number? Because if you can make that a whole number, then that is the first step, is try to simplify any fractions as possible inside your radical before you do anything else. So step 1, simplify fractions. And so in this case, I've pulled out my calculator, and 80 over 5, or you could do 80 divided by 5, and that gives us 16. So that's really nice because that gives us a whole number. And so it simplifies to the square root of 16. And then we can actually take the square root of 16. That actually comes out to a whole number here. And so square root of 16 is equal to 4. So this one's actually pretty simple. You just have to make sure that you simplify the fraction first, and then you take the square root if you can, and we just get a whole number. Now the one on the right doesn't exactly work the same. I mean, we're still going to do the same thing. We're going to try to simplify the fraction, but it's not going to come out to a nice whole number. We're still going to have things left over with the square root. So we've got 200b to the 11th power over 2b to the 5th inside our square root symbol. And so the first thing we can do is the 200 over 2, and we can divide that. 200 divided by 2 is 100. So we can create that as 100. And then on your exponents, the rules of exponents say it's the top minus the bottom. So I'm going to write that out just so that I have that. It's going to be 11 minus 5 as our exponent. Make sure that 11 is more separated. And so this is going to give us 100, and then 11 minus 5 is 6. So we get 100b to the 6th. So now we just simplified the fraction part, and now we're going to simplify the square root. And we're going to be using the multiplication property here. Because I can split this up so that I have the square root of 100, and then I can split it up so I have the square root of b to the 6th. That's a really nice handy thing when you have like a number and a variable that you can split those up. And so we can take the square root of 100, it's a perfect square, and so that comes out to 10. And then we need to figure out what do we do with that b to the 6th deal. So the general rule is this is a square root, which means that there's basically a 2 on the outside. And so we want to kind of rewrite this as powers of 2 so that we can cancel things out. So we've got b to the 6th, but we want powers of 2 since it's a square root. So I can write this as b squared times b squared times b squared. So that gives me 2 plus 2 plus 2, that gives me 6. So I will still have 6 b's there. I've just kind of grouped it in pairs so that I've got all of these square roots and all these things that are squared. So I can split this up. I can make each one separate. And the square root of something squared cancels out. So I'm going to be left with just b for each of these, because the square root is going to cancel the square. So each of those is going to get me a b. So I have b times b times b, which then we can write as b cubed. So we've just simplified this, and yes, go ahead, ask your question.
Could you have just gone for b to the third times b to the third?
Yes, yes, that is actually what I was going to get to next, is that instead of like doing what I did with b squared times b squared times b squared, I could have written it as b cubed squared and then the square root and cancel it out that way. So that actually is not the first thing that a lot of people think of. So that's why I didn't do that for my first one. But that is the more efficient way to do this. And the most efficient is to basically see that whatever your exponent is on the inside, you can divide it by the little index on the outside, and then that will be your answer when you remove it from the root. So we have b to the sixth. 6 divided by 2 is 3. So when we take the square root, it's now a 3 outside when it's outside the square root, and we get b cubed. And that's because if you write the b to cubed and then squared, you're basically splitting that 6 up as something times 2, and then the 2's basically cancel and you're left with that b cubed. So that's the most efficient way to do it, but sometimes that's harder for people to see. So I first did the b squared times b squared times b squared, so you can see that you can also get your answer that way. Any other questions? Okay. So that's basically the rules, the basic rules when we're simplifying. We've got fractions inside here. So now we're going to get a little more complicated, or do a little bit more, and this is where the order of operations comes in, because when you're simplifying something like this, you have to know what order are you doing things. So I've got 5 times the square root of 18 over 3. And 2 times the square root of 27 over 6. So our order of operations, we use the abbreviation PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. So square roots are at the same level as the exponents, because the definition of a square root is actually the same thing. It's an exponent, it's just an exponent of 1/2. So those are done at the same time. So when you're simplifying something like this, you need to actually simplify your square root before you do any multiplication, division, addition, or subtraction. So like on the right, that 2 over 6, you don't want to reduce that yet. You want to simplify the square root first, then you're going to have to then do some multiplication and division. So this is really where the order of operations comes in, because simplifying the square root happens before we do anything else. So on the left here, we have 5 times the square root of 18 over 3. So the first thing we have to do is simplify that square root. And so for 18, we want to simplify it in such a way that we have a number that we can take the square root of. And so sometimes it helps to kind of separate out your fraction part from your square root part, so that you're just working with the square root. So you can see this 5 times the square root of 18 over 3, you can read it as 5/3 times the square root of 18, if it makes things a little bit easier so that you're not kind of getting confused with what's going on. So 18, I know that it's 9 times 2, and I can take the square root of 9. So that's why I want to split it up that way, is because, I can take the square root of 9, so that way I can remove that from the square root, and then all I'm left with is the square root of 2. So we've got 5 over 3, and then really what we're doing here is we're separating out those two square roots. So then I have 5/3 times, and the square root of 9 is 3, and then I have my square root of 2. And so now here is where we need to do the order of operations. We're doing our multiplication and division for the order of operations here because we don't have any addition or subtraction. So the 3's actually can cancel out because I'm multiplying by 1, and then the fraction is basically I'm dividing by 1. And so I can actually just cancel those out. Otherwise, if you wanted to, you can do 5 times 3, which is 15, and then divide by 3. You're going to get the same answer. But we're basically doing our multiplication step. And so this is then going to leave us with a 5, and then times the square root of 2. And we can't combine those because one is outside a square root, one is inside a square root. So you're just left with this thing that has a whole number in front and then a square root, and those are multiplied together. And so there are some things we can do with square roots, like add them and subtract them. And to be like terms, the square root part has to match. So if I wanted to combine this with something else, it would also have to be something that has a square root of 2. So you can kind of think of that square root thing as like a variable just kind of hanging out there in the end. So that's how you would simplify this one on the left. Now the one on the right, we're going to do the same sort of thing. So we've got 2 times the square root of 27 over 6. So we need to simplify the square root of 27. And I look at that and I think 9 times 3, and that I can use that square root of 9 again. So I'm just going to do the same thing. 2 over 6 times the square root of 9 times 3. And then I can split that up as the square root of 9 times the square root of 3. And the square root of 9 is 3. Oops, and I just converted my 6 to a 3. Didn't mean to do that. And so we can simplify fractions right here. Or you can multiply and go 2 times 3 is 6, 6 over 6. Basically, these are going to cancel out because if I divide 6 by 3, oops, I get a 2 left over. I try to cancel those out, and then I can cancel those 2's out. So I'd basically end up with no number in front at all when I start doing the multiplication and division. When you're simplifying or you're multiplying these together, you would do 2 times 3, which would be 6, and then 6 over 6 is 1. So you basically have no number there, and so that all cancels, and your final answer is just the square root of 3. Are there any questions? Okay, so this is sort of like getting you to the spot of the quadratic formula where you have a square root on top of a fraction and kind of how you simplify that stuff out. So when you're using quadratic formula, you're more likely to see things like this, where on the top of your fraction, you're going to have things that are added and subtracted with square roots, and then you have this fraction. And so again, we need to follow the order of operations here in order to simplify these. So we're going to do our square roots along with the exponent part. And then because we have a fraction, we need to simplify the top of the fraction first before we simplify the fraction itself. So then we're going to have to do some addition and subtraction because the order of operations is to simplify each part of the fraction first. And then we'll simplify and do any division that we need after that. So once again, step 1 is to simplify the square root. And in these cases, These both come out to whole numbers, and actually I think what I'm going to do is change, instead of the square root of 81, I want to put something in there that's not going to be like perfectly, let's do 32 instead, just because I want to show what would happen if it was, see, that blends in too much. I want to do something that's not a perfect square. Actually, let's not do 32, let's do 48. So pretend it's a 48 inside that square root instead of an 81 for that one on the right. But let's do the one on the left first. So we need to take the square root of 25, which in this case comes out to a whole number, that's 5. So we get -1 plus 5 over 4. So step 2 is we need to simplify the top. Simplify the numerator. So that's what we do with the order of operations. We have to simplify the top and the bottom separately before we do anything else. So -1 plus 5 is equal to 4. And then, of course, step 3 is to simplify, or basically to do the division. And 4 divided by 4 is 1. So this will give us an answer of 1. Now let's look at the one on the right. And I changed it so it doesn't come out to, it's not a perfect square, so we're still going to have the square root be a little messy. So we've got 3 minus the square root of 48 over 3. And I want to make sure that that whole thing is on top. So I chose 48 special, but basically 48 is 16 times 3. So we're going to try to simplify that square root of 48. And that is 16 times 3. And so we can separate out the square root of 16 times the square root of 3. And then the square root of 16 is 4. So 3 minus 4 square root of 3 over 3. So now we want to split this up, because on the top here we can't actually simplify the numerator, because I can't do 3 minus 4 square root of 3, because the 4 has a square root of 3 but the 3 doesn't. So these are not like terms, because they don't both have a square root part. So you can kind of think of that square root part as just like, it acts like a variable. It has to have the same rules, where they have to match, and they don't match here. So in order to simplify this, we have to actually split this up into 2 separate fractions. So when you're adding or subtracting fractions, the denominator has to be the same. So when you undo it, you get 3 over 3 minus 4 over 3, and then the square root of 3. So what you do is you basically put the top, everything on top, over the same denominator that we had. And then we can simplify further. We can do 3 divided by 3, which is 1. I don't have any more room on my screen. You guys see more black than I actually have room to write on my own thing. But we can't simplify the 4/3. So we end up with an answer that looks kind of messy here. It's 1 minus 4/3 square root of 3. But that is the simplified form, because we're trying to make what's inside the square root as much as possible, and then if we can get like a whole number part out of there, we can. So this is the kind of thing that you're going to get a result of when you're doing the quadratic formula. So when we're solving a quadratic equation, factoring is the best way to solve but that doesn't work all the time. Factoring only works if you basically have answers that are whole numbers or fractions, but it doesn't work if you're going to have numbers that are decimals. The quadratic formula is how you get those answers, but we don't like to write the answers as decimals because we have to round. So instead, they get written in this format using square roots, but at least that's the exact version, so you don't have to do any rounding of your decimals. So that's why we have to kind of learn how to do this with square roots, is because that other way to solve a quadratic will involve taking square roots of numbers. And just as a general rule, we don't like to have decimals whenever possible because we have to round, and then it's not 100% accurate anymore because now it's a rounded version of the actual number. Are there any questions? Okay, so these were all the examples that I had, because you'll get to practice this once we get to the quadratic formula, which I've got videos on the quadratic formula, and so you can kind of see how that works here. But this at least gives you enough that you kind of have an idea of what you need to do. How can I hate this type of math less? I don't have an answer for you, because square roots, a lot of people dislike doing things with square roots. For me personally, I find it enjoyable because I like the simplifying process. And I often do the simplifying process using prime factorization and making those factor trees. And I just kind of enjoy doing that sort of thing. So maybe if there's something in the process that you enjoy, try to focus on that and find joy, even if it's not the whole process, but maybe there is one particular part of the process that you enjoy. Try to find, just try to enjoy that while you can. But there's not going to be every part of math that you like doing. You may enjoy factoring, but not like doing other things. And so that's the best advice that I can give you. It's one of these things is like you just, if you have to solve quadratic equations, you have to know how to do this, and that's just the way it is. And sometimes you have to do things that you hate. There are other questions? All right. Well, since there's no other questions, I will stop the recording.